Felix. Felix, the floor is yours. Please start your presentation.
Okay, thank you, Paul. Can you see the presentation?
Yes, we can.
Okay, thank you for the invitation. My name is Felix Larrinaga. I'm a researcher at Mondragon University. And what I will present today is the work of one of our PhD students that recently finished his work. And it is related to workflows, dynamic workflow orchestration. And first of all, I will try to put into context his research, and then I will show you the architecture that he proposed. Okay, a little bit of background. We started collaborating in Arrowhead almost from the beginning of the Arrowhead existence, and we very early focus on workflows, mainly on the part of the choreographer and the workflow manager at the moment. We study using different tools available in the market, like WSO, and also we implemented a workflow manager in Node-RED, trying to use and accommodate to standards that already were available, like BPMN, which is a business process modeling notation, and also always with the objective of integrating those processes into industry. So this research came as a result of that, and also we collaborated in Arrowhead in parts related to workflow orchestration, and also implemented a Node-RED module that enables to build applications in using Arrowhead. So with that in mind, what I will present today is how this researcher proposed an architecture to easily adapt assets, different devices that are in the shop floor, and build workflows that dynamically could select the best option to work in a specific moment, depending on the context. So we focus on workflows, as I said. We simulated or assets with multiple capabilities, and also we try to align with the standards for interoperability as asset administration shell and business process modeling notation. So the architecture he proposed is summarized here, and the idea is that in a plant we have different assets. Those assets can be represented with their digital twins, which is this representation that you can see here. Those digital twins can be registered in servers that represent what the plant or the factory is capable of, with a discovery system that the asset administration shell offers, and the functions or the functionality those assets provide can be discovered and consumed from this asset administration shell platform or framework. So our idea was to build business process models, as you can see here in the bottom part, with a modeling tool. Those are translated into recipes, and those recipes can be executed in a business process modeling execution platform. It could be any of the platforms that you can see there, WSO2, but we implemented one ourselves that was able to read BPMN recipes and ask the different assets for the functionality that the workflow requests at a given time. So the main contribution for this researcher was to provide another system, a context analyzer, that collected information in relation to the quality service of those assets, the disponibility, the battery, the conditions that we specify, and include those in the business process notation in such a way that in a given time, during the runtime, we could ask this context analyzer, and the context analyzer will tell us which is the best asset to select for a specific task in a given moment. So that is the overall idea. And well, next slides is a bit of the details of the technologies and the things that we have implemented in each of these modules or components that you can see in this architecture. The idea is just to show you a short simulation video that this student prepared. So for the modeling, one of his contributions was to build a plugin that enabled the modeling tool to incorporate asset administration shell in the construction of the recipes. So with this plugin, you could discover what the asset administration shell framework offered, what was registered there, and include those the task that those devices could perform into your business processes. So he built it in Camunda, and the idea was to just select a given service and include it in the recipe. Also, in those recipes, you could specify the quality performance that you require for a specific task. So, like in this case, what he was requesting is, in order to collect, let's say, we will see a demonstration with some robots in a layout, some robots that they need to pick up. They need to pick up given material. They need to provide information about the battery, the payload capacity, the position in the plan, and how, where are they located. And with that information, during runtime, the workflow executor will query the context component, context awareness component, and that information will be used to select the service, the best service for that specific time. So we could include those quality that quality information in the actual recipe itself and be able to execute it. We had another simulation just to show how our business workflow executor built in Node-RED was able to read recipes and well, do a flexible task. I mean, we could change the recipe and tell the asset if the asset was able to do different functions to perform tasks to compose some kind of a product at the end. So this other component is built in Node-RED, and we also made a module for Arrowhead built in Node-RED, so all the functions could be also Arrowhead compliant. Well, this is just some of the. Well, we implemented this in a Lego environment, but it is embedded in the Raspberry. This workflow manager could be embedded also in a Raspberry Pi or an embedded system, and it could run in that system. And then for the component, for the context analyzer component, we use well, the principles that I follow was the MAPK reference. So to monitor, analyze, plan, execute, and he used for these semantics. So he could register the information that he was collecting from the assets in a semantic repository according to an ontology, and then with that information inform the workflow executor about which was the best asset for a given in a given moment. And the best is to present the case. This is the video I will show you in a minute. It's not very long. The idea is in a workflow process, the very last task of the process was to select a Carter robot among different robots in a layout in a plan. This is a simulation that the student ran. So the idea was to provide some obstacles, and there was a pick location and a delivery point. These robots were distributed randomly here in the layout, and the idea was to, by means of the contest awareness system, to tell the workflow executor which was the best Carter robot to select to pick up the given components or the necessary components and bring into the delivery location. So for that, he took into consideration the battery, the proximity, the payload capacity, and another quality, but mainly those. And with that, where he used these robots were they run on ROS operating system, and the simulation was done with. I'll show you here in the video. Just one second. Well, these are some of the publications that this student performed. Let me finish this and go to the video. Okay, please let me know. You can see the video, right? So this final part, it says in the warehouse is based on ROS operating system robots, and the idea, the simulation was, well, this is the architecture I mentioned. Let me go a bit further. Well, this is the context analyzer. Okay, let me stop this. It's run in the simulation environment is NVIDIA Isaac Sim, and also for the robot navigation, he used ROS as the operating system and RVs for the navigation. So, okay, well, you can see this is the environment he used, but what he did is he created 10 robots. You can see them here. Initially, they are placed in the initial point, but then it gives them a random position and random quality measures or values. So each robot has a battery, a position, and a location, and the robots will take the positions when the simulation starts. So it will give them all the random values that I said. So you can see that for each robot, it has a different payload capacity, a different location, a different battery measure, and now you will see it in the environment when you place them in the layout. So as I say, these are the considerations. Sorry. This is what we're taking into consideration: 20 meters, a battery less than 20 meters, more than 25% of the battery capacity, and centrally is the robot can get lost, and depending on that, if the robot thinks it's lost, we take this into consideration as well. and also the payload capacity. There is a minimum for the thing that the robot had to carry. Let me skip a little bit this. So each one go to the initial position. Now they're moving to the random position that they got. And once they reach the random position, we simulated with the context analyzer which robot was the most. I mean, the context analyzer provide the business process executor which was the best robot, and that is the robot that went to the pickup location, which is here. This is the pickup location, and then delivered to the delivery point. I think they are finishing with the position because sometimes the robots get lost or they collide with each other. But I think in a minute it will assign one of them. I think this is the one. So the robot will go to the pickup location. No, now this is the initial position. And now is the time. So now I think it has selected this one. Probably this one doesn't have enough battery, or maybe other conditions or uncertainty because it may be blocked for this. But it has selected this, depending on the criteria that I mentioned before. So it's going to the pickup location. And then it will simulate that it's taking the components or the necessary components to the delivery location. So we're trying to find a scenario where this was valid, and that we selected this one to test with and without the context analyzer, and the results that we get were quite. There was an improvement, obviously, because you are selecting. I mean, instead of selecting a robot that could not meet the necessary quality conditions, but we always selected the best robot. So we save in time and also accomplishing the task that or the workflow that need to complete. So, well, this is very brief, the information. Perhaps if you are interested, we could discuss more in detail any of the parts of this architecture that I just very fast mentioned. But in case you are interested, we can share publications or thoughts or whatever you feel like. So that's it. I don't know if you have any questions.
Thank you, Felix. I stop the recording, and we should have questions.
Let me stop the sharing.